If you recall, we have discussed in the last class about this Terjagi's bearing capacity theory, which is very, very important. Okay. So here Terjagi has assumed base of the footing as rough, and it is valid for strip footing, that you should remember. Okay. Here it is strip footing, and uh, for a shallow foundation. And finally, what we have done, it is replaced with surcharge here, and this particular footing, this will act as a part of the footing, and these are the radial shear zone, this is the passive zone, and so on. We have done vertical forces, downward forces equal to upward forces, and finally we got this equation. Or this one, this equation. Okay, anything is okay. Here Q naught is equal to gamma df surcharge. So and he says this NC, NQ and N gamma are equal to this one, and it depends on the only 5 values: shearing resistance or angle of internal friction. Understand? And he has given the tabular column even graphs also for this NC, NQ and N gamma. So once we know NC, NQ and gamma in this bearing capacity equation, C we can find out gamma df, depth of the foundation we know, unit rate of the soil we know, and width we are providing we know, gamma we know. So we can find out the ultimate bearing capacity. This is the ultimate bearing. Once we find ultimate capacity, other capacity if we want we can get it. Okay, whether it may be net ultimate or net safe and so on, gross safe and so on. That those definitions we have already seen. Now, Terjagi says for general shear failure, he has given these values NC, NQ, and N gamma. For local shear failure, it is represented by dash, NC dash, NQ dash, and N gamma dash. So, what is this general and local shear failure is all about? Okay. So here there are three types of failure. Okay, general, local, and punching shear failure. Here you will see the punching shear failure, punching shear failure. So these three failure will happen when you try to apply a load. Here, if you see, this is a general shear failure, this is the local shear failure, and this is a punching shear failure. So what is the difference here is, in a general shear failure, if you draw load versus settlement or intensity versus settlement, so you could see the sharp failure of this graph. Okay, so all of a sudden it will try to fail it. It won't carry any load further. Okay, this kind of failure is called the general shear failure, and this would happen in the gravel soil, sandy soil. Okay, so gravelly sandy soil with dense gravel and sandy soil. Here, if you see this, if this is the foundation, this is the elastic equilibrium, this is the radial shear zone, passive zone. What he says is there will be huge observation. The soil will bulge in both the side. This is the bulging. Both the side, he says the soil will try to bulge it in the general shear failure. Understand? Now coming to the local shear failure, here everything is same. Here also could see little bulging and other thing. The only difference is after failure, what happens? There would be some jerk, and there would be some more settlement here. This settlement. After failure, soil there will be some jerk in the foundation, and it will settle down. Here, all of a sudden, okay, there is no settlement. So then from here to here, this is called the settlement zone. There will be jerk, and this kind of failure will happen in the medium dense and the medium soil. Next is punching shear failure. Like the name suggests, you will not see any failure pattern, Terjagis and heave and other thing. It happens for the soft soil. loose and soft soil. Here also we see little bit jerk and these things, but no soil bulging and other things you could see. Just a punching because it is very soft, right? So these are the three failures given by the Tirjagi. Now, if you go and read it, no, not given by Tirjagi. Basic has given this one. Okay, so this fellow also very important. So we will, there are basics theories and so in when you do MTech and all. Okay, so general shear failure figure what we have seen shows a strip footing resting on the surface of a dense sand or a stiff clay. So this will happen on a in a dense sand and a stiff clay. The figure also shows a load settlement curve for the footing where Q is the load per unit area and S is the settlement. A certain load intensity equal to QU, the settlement increases suddenly. Okay, that point is very important. A shear failure occurs in the soil at the load and the failure surface extend to the ground surface. Okay, so there will be some bulging. This type of failure is known as the general shear failure. A heave on the sides, both the sides, okay, is always observed in the general shear failure. So these points are very important for your gate exam and the all competitive exams. Okay, what are different types of the failure in the soil? In which soil this heave will happen, whether it in bunching or shear or local shear failure and so on. Okay, so general shear failure occurs in the dense sand, okay, and stiff clay. In local shear failure shows the stiff footing resting on the medium dense or an clay of medium consistency. So this local shear failure happens in the medium dense, not very dense. Okay. When the load is certain is equal, value, the foundation movement is accompanied by the sudden jerk. This is very important. The failure surface gradually extend outward from the foundation as shown in the figure. Okay. However, the considerable movement of the foundation is required. Here, to happen this local shear failure, considerable movement of this foundation is required for the failure. Okay. Jerk will take place and little movement of the foundation, then soil fails. Okay. Those things are shown with the dotted line. Okay. The load at which this happened is equal to the QU, and beyond this point an increase of load is accompanied by the large increase in the settlements. Okay, so there would be some increase in the settlement. Now coming to the punching shear failure, this happens on a loose and the soft clay. This is very important. Okay, and failure surface do not extend to so there won't be any heave and other thing. Okay, there are little jerks in the foundation at the this one Q01. The foundation fails at the load Q at which the stages of settlement curves become the steep and practically linear. Okay, this type of failure is called the punching shear failure. No heave is observed here. There is only vertical movement. Understand? So this is all about three types of failure, and this graph is given by Terzaghi, where here the SPT values are given. Okay, and once you have SPT value, we can get NC, NQ, N gamma by using these graphs. Once you get once you get this N gamma, we can find out the ultimate bearing capacity. That means what we are doing here is we are using these SPT values to find the bearing capacity of a soil. Understand? That means go and conduct the SPT, get the N values, and then what you have to do is find out the NC into N gamma and apply those NC into gamma for a bearing capacity equation. QU, ultimate bearing capacity of Terzaghi's equation. Unit weight of the soil we can easily find out, and we can find out the cohesion and 5 parameters and all. So there are some more important points. Okay, So basic proposal relations for the mode of failure based on the relative density. Okay. So and df by b star, where b star is the 2b multiplied by L divided by B plus L, in which B is the width of the foundation and L is the length of the foundation. Okay, length. So it is worth noting that even for the same relative density, the mode of failure may change with the change in the df by d dash ratio or d b star ratio. That means the relative density can be same, but what is basic says is the mode of failure depends on the depth of the foundation divided by B star, the B star value he has given. Okay. So it is generally observed that for a shallow foundation, the ultimate load occurs at a foundation settlement of 4 to 10% of the B in the case of general shear failure, and at the settlement of 15 to 25% of B in the local and punching shear failure. This point also important. Okay. In a general observation, in a shallow foundation, the ultimate load occurs, okay, before failing, where the foundation settlement is between 4 to 10% of the B is the width in the case of general shear failure, and 15 to 25%, obviously, because in local shear failure and punching shear failure, settlement would be more. Okay. So 15 to 20% of the B settlement of the other failure will occur, punching and this uh, local shear failure. As the footings are seldom constructed on very loose sand, the punching shear failure rarely occurs in the practice. It is not much practical importance. Okay. So Terzaghi consider only general and local shear, because when the soil is soft, anyway, we are not going to construct any foundation on that particular soil. Okay, soft soil. In that case, Terzaghi has neglected this particular parameter for failure, that is punching shear failure. He focused mostly on the local and general shear failure. That's the reason he has given values for general and local shear failure. And so how the bearing capacity will change, actually, this NC, anyway, tabular column he has already given. So how this NC, NQ, N gamma dash, generally we have to take it. Again, it is he is explained here in the next section. So ultimate bearing capacity in case of local shear failure. So what he says is, this is what this basics has given the graph. Okay, it depends on the not relative density, not on the relative density, but on this ratio. So based on that, this comes under zone 3, zone 2, and zone 1. We can find out, okay, which zone it is. Now, now we are focusing on this Tirjagis. What Terzaghi says is, for a local shear failure, okay, he is focusing on the in case of local shear failure, how the equation will change. What he says is, for a local shear failure, he has suggested the following empirical relations, okay, for a cohesion in the case of the local shear failure. What he says, the mobilized cohesion he has taken, CM. What he says, it would be equal to 2/3 of the C dash. C dash is the actual cohesion, whatever we are finding. Suppose in the exam, if I say that the soil fails, there is a local shear failure for a foundation. In that case, with C, you have to use mobilize C. Whatever C you got it, make just 2/3 of that one will give the mobilize C for a local shear failure. Same thing, mobilized shear angle also will consider. Okay, instead of phi, whatever, where generally we use this phi, to find out this NC, NQ, and gamma. There are relations are given, right? This is for general shear failure. Okay. For NC dash, NQ dash, N gamma dash, what we can do is you just substitute the mobilize angle of internal friction. Okay. So this value you have to, which would be equal to the tan inverse of 2/3 of tan phi. That means first what you have to do, tan phi we have to calculate, then we have to, what you have to, Or you can remember in this way, tan phi m is equal to 2/3 of tan phi. You take this tan phi here. So mobilized tan phi m is equal to 2/3 of the tan phi dash. Understand? So by doing this one, what you do, you will get it is all our values you will get it. This will change, our equation will change. Now equations becomes C is equal to 2/3 of C, NC dash, NQ gamma dash, and NC dash, NQ and N gamma dash. So all dash will come into picture here. Dash means local shear failure. So the reduced values of phi dash equal to the phi m are used to determine the bearing capacity parameter from the values of the general shear failure. Okay, so modified bearing capacity factors indicated as NC dash, NQ dash, and the N gamma dash for local shear failure. And figure 23.10 gives the values of these factors. We have seen that one, and tables also gives. Okay, now so basic also has given. Okay, so the 23.1 also gives the values for these factors for phi dash. It has been found that from the several model tests that the values of NQ gamma as determined above is underestimated. Sometimes the following equation can by given by these basics also can be used for the local shear. He has given some separate equation for NQ gamma dash. Okay, that also can be used, but you remember this one. Whenever we talk about mobilize or a local shear failure, we should take this mobilize C and the mobilize phi. That you should remember. Okay, those things are important. Now here there are some important point here. Look at it. For a cohesionless soil, if the phi is greater than 36, general shear failure likely to occur. That means it depends on the phi value. Phi value in the sense more dense. Okay, 36 means soil comes in the dense condition. If the phi dash is less than 29, the local shear. That means based on this our phi values, we can easily identify that the soil fails in general shear failure or local shear failure. Easily we can find out. For general shear failure, very important point this one. Okay, they will ask in the gate also. For a general shear failure, angle the phi value generally would be 36. If the phi is less than 29, then local shear failure will occur. For the intermediate values of phi between this one, the values of bearing capacity factor are obtained by interpolation. We can do it. Okay. So like this, some example has given. Okay. So what is this? What is this graph is all about? Bearing capacity for local shear failure, and here basic and Terzaghi both are given here. So NC, NQ, and gamma. So directly we can find out this NC and gamma. Understand? So graphs are given. Angle of friction, if you know, okay, 36 means it comes to the, these are the values you will get it. Then it falls under the, suppose value is 36 here, okay, phi value. Then you find out this N gamma, NQ, okay. Forget about basic, we will focus on the Terzaghi and this NC dash. If you substitute here values, no, from this graph, then you will find out the ultimate bearing capacity. So that's what it is given. Okay, some example it is given, and the actual value of this more than this one, and that's what it is given here. If you read it, the example is given. How to find out the NC, NQ, and the N gamma. And then let me check any important points. If the failure of the specimen of the soil occurs at a relatively smaller strength, say less than 5%, the failure of the footing would be general shear. Now, focus on this second point. What we said previously is if the phi value is 36, then general shear failure will occur. Now, one more important point is if the failure of the specimen of the soil occurred at a relatively small strain, if you find out the strain, okay, say less than 5% of the failure of the footing would be by general shear failure, because in the general shear failure, strains would be very less. There won't be vertical movement of the foundations. Okay, so what happens if the strain is less? That means general shear failure would occur. If the stress strain curves does not show a peak and continuous rising curves even up to a certain strain like 10 to 20%, then we should suspect, and it may be because of this local shear failure. That means for a local shear failure, more strain occur in the footing. Understand? If the relative density is greater than the 70%, then what happens? Definitely relative density more means dense, very dense, and general shear failure would occur. If it is less than 35%, local shear failure will mostly occur. If the standard penetration test value is more than 30, the general shear failure will occur. If the SPT value is less than 5, the local shear failure will occur. So we are not talking punching here, okay? So general and the local shear failure, general and the local shear failure. So it depends on the, I hope you understood, okay, what is general shear failure and local shear failure. It can be find out based on the SPT values, it can be find out based on the phi values, it can be find out based on the strains, observation of the strains, it can be find out based on the relative densities, how much relative densities is having, okay. And is if the wide ratio is less than 0.55, the general, again it is given the fifth point based on the wide ratio also. Then because more wide ratio in the sense the soil may become clay soil. So if the wide ratio is just 0.55, general shear failure would occur. If wide ratio is greater than 0.75, the chances of local shear failure would be more. Understood? So this is all about this general, local, and this punching shear failure. So with that, today I will stop. Okay, please keep reading every day, then only you'll understand. Okay, so today we have covered this particular figures and try to understand it, read it again, and try to digest. And because if you want to write gate exam and other things, each and every points are important here. So you can check some competitive exams book and follow. Okay.